Hi everybody, it is time to make a video for worksheet 10-2, which is about lines that are tangent to a circle. I think that this is a little bit easier than 10-1, which is nice. So first of all, number 11, segments DF, DH, and GF are tangent to the circle. Andrew was asked to find DF. Explain Andrew's error. So Andrew said that DF was equal to DE plus EF, which is true. But then he said DF was equal to 6 plus 6 because he thought that EF was 6. But according to the two-tangent theorem, EF is 8. So DF equals 14. That's too thick. So DF equals 14 because EF is equal to FG. Because EF equals FG, and both of those are equal to 8. By the two-tangent theorem. By the two-tangent theorem. Next, the segments A, B, and C, D are tangent to T. Find each value. So if we're finding A, B, what we know is a few different things. We know that if the segment TB is 6, then the segment from T to the edge of the circle is that same amount because it's the radius of the circle. Then I noticed that AT is 12 and BT is 6. I know that this has to be a right angle because the tangent is perpendicular to the circle. And also I know that the hypotenuse is twice as long as the short leg. Any triangle that has a hypotenuse twice as long as the short leg is a 30, 60, 90 right triangle. And if ABT is a 30, 60, 90 right triangle, then BT is 6 and AB is the longer leg, which is 6 root 3. So AB must be 6 root 3 because that has to be a 30, 60, 90 triangle. For number 17, the measure of angle TDC is going to be right triangle stuff. I know that 8x plus 2 plus 4x plus 4 needs to be equal to 90. Plus 2 plus 4x plus 4 equals 90 because that's 180 degrees in a circle and 90 of them are for the right angle. So if you solve that, you've got 12x plus 6 equals 90, 12x equals 84, and x equals 7. Then we want to find the measure of angle TDC, which is the 4x plus 4. So we'll do 4 times 7 plus 4, which is 32 degrees. So the measure of angle TDC is 32 degrees. Number 18, we want to find each value. We see that 2x plus 4 and x plus 7 are both tangent to the circle. Using the two-tangent theorem, we know they're the same. So 2x minus 4 equals x plus 7, and we can solve that equation. We find that x equals 11. So we can plug it in for FE or DE. 11 plus 7 is... sorry, I'm not finding those values. I'm finding DG. So DG is this one right here, the radius. GF is the same. So DG is going to equal x minus 2 as well. So 11 minus 2 equals 9. So DG equals, not D, equals 9. Okay. Number 20, AC. This one is pretty simple because all we need to know here is if we're finding AC, AB is going to be the same as FE because of these tangents being the same. So that's 29. And I also know that angle B needs to be a right angle because BC is tangent to the circle. So it's a right angle. I know BG is 9 because GE is also 9, and those are both radii of the circle. And GD is also 9 because that's a radius of the circle. So GC is 32 plus 9. 32 plus 9 is 41. 41 is the hypotenuse of triangle GBC. we can use the Pythagorean theorem to find the long leg, or BC, by saying 9 squared plus x squared equals 41 squared. When we solve the Pythagorean theorem there, we get x equals 40. So BC equals 40. So AC, what we're being asked to find, is 29 plus 40, which is 69. All right. Next, 22, the diameter of circle F is 8. Immediately that rings my bells and says, oh, that means that the radius of circle F is 4. AB is 10. BC and AC are tangent to F. Let's see. So if this is 10, I know the radius of the circle is 4, which means if I go kind of across this way, that's also 4. But it also means that this piece is 4 down here, and then the piece of the top of the tangent must be 6, since 4 plus 6 is 10. I also know that because of the two tangent theorem, the piece from B to this tangent is 6, the same as it is on the other side. What else do I know? I know that this piece down here is 4, because it's the same as the 4 up above it. And then what I don't know is the last two pieces. But both these pieces come from C, and they're tangent to the circle. So both of them need to be the same amount. I can call them x and x. So what I can do is I can use the Pythagorean theorem. But with the Pythagorean theorem this time, I'm going to have to use some expressions like x plus 6 and x plus 4. So I can say x plus 4 squared plus the leg on the vertical, which is 10, equals my quantity for the hypotenuse, x plus 6 squared. So then we have to solve this out, right? Remember, x plus 4 squared is like x plus 4 times x plus 4. So let me write that out. That's going to be x squared plus 8x plus 16, because we sort of have to multiply everything multiplied by itself, right? Kind of like FOIL, if you learned with FOIL. Plus 10 squared, which is 100. X plus 6 squared, same thing. That's x plus 6 times x plus 6, which is x squared plus 12x plus 36. Then we can solve here. We can simplify. So we've got x squared plus 8x plus 116 equals x squared plus 12x plus 36. Solve the equation. We can just subtract x squared from both sides, and it goes away because it's on both sides. 8x plus 116 equals 12x plus 36. Subtract in there and solve. Subtract 36. We get 80 equals 4x, 20 equals x. And the question is, what is the perimeter of triangle ABC? So triangle ABC has a side that's 10. It has a side that is 20 plus 6. And it has a side that's 4 plus 20, or 24. We add those all together, and we get 60 for the perimeter of the triangle, which is the answer to the question. Number 23, Yumiko is shopping for a stand for a decorative glass ball with an 8-inch diameter. She is considering the stand shown and wants to know the height h of the portion of the ball that will be visible if the sides of the stand are tangent to the sphere. What is the value of h? So we've got a lot going on here. Let's think. So we can say for sure that since the diameter of the ball is 8, the radius of the ball is 4. So I know that from the center of the ball to the top of it has to be 4. So those 4 inches are definitely showing above. We need to figure out the rest of the inches that are showing, which is this piece right here. Got to find out how many inches are showing above the base. We know it's less than 4, but I also know that I can draw a 4 right here. I can draw a 4 right here because that's another place we can see the radius of the shape. And what else do I know? I know that this is 5. Okay, cool. Let's keep going. If this is 5 and this is 4, what else can I do there? Ooh, I can make this into a couple of different triangles. All right, what I want to do is I want to find the measure of this angle right here. And I'm going to do that using tangent. I know that there's a right angle here because that's tangent to the circle that 5 inches is. So I'm going to look at the triangle that I can make that is a right triangle here. And I can use that to find the measure. So if I say the tangent of, I'll call that angle a different letter besides x. No. Maybe I'll call it angle y. So I can say the tangent of y is equal to opposite over adjacent, 5 over 4. And I can find the inverse tangent of both sides to say, okay, that means that y is equal to 51.34. That's the inverse tangent of 5/4. So this angle right here, angle y, is 51.34. Now I can look at a different right triangle. I can look at the right triangle from the center to the base here. This is another right angle. And I know an angle measure, and I know a side length. I can use cosine to find the measure of angle x. I can make an equation that says the cosine of angle y, 51.34, is equal to adjacent x over the hypotenuse of that red triangle, which is 4. All right, so then I can say, all right, well, the 4 cosine of 51.34 is going to be my answer there. 51.34 equals x. That is 2.5. So this piece right here, x, is 2.5 units. That means that the portion of the ball that will be visible is going to be that 2.5 centimeter section plus the 4 centimeter radius of the ball up above here, this segment right here, which means altogether 6.5, I guess, inches, not centimeters, 6.5 inches of the ball will be visible. That's probably the trickiest problem on this section because we bring back in the trigonometry there. Number 24, Samantha is looking out from the 103rd floor of the Willis Tower on a clear day. How far away is the horizon? Earth's radius is about 6,400 kilometers. Let's draw Earth because we're going to need it here. So we've got the radius of the Earth. That's 6,400. And we'll say kilometers. We've got the Willis Tower, which we're going to exaggerate greatly. And from the top of the Willis Tower, we're going to look at the horizon. So we're going to look tangent to the circle at the horizon. And we are trying to figure out how far away the horizon is. That would be x there. So I know a few things. I know that the radius of the Earth is 6,400, and anywhere that I draw the radius, so over here as well, that's 6,400. I know that the Willis Tower is 412 meters tall. I'm going to turn that into kilometers by moving the decimal 3 points to the left, so 0.412 kilometers tall for the Willis Tower. And I know that anything tangent to my circle will be a right angle. So I have this right triangle. This right triangle has a short side of 6,400. It's got a longer leg of x. And it's got a hypotenuse of 6,400 plus 0.412. So I'm going to write that as 6,400.412 squared. And I'm just going to do the Pythagorean theorem. So if I solve this, I find that x squared is equal to 5,273.77. And if I take the square root of both sides, I find that x is equal to 72.6. 72.6 what? We did our measurements in kilometers. So 72.6 kilometers is how far you can see from the top of the Willis Tower. Next, 21. Line M is tangent to circle A at B. What is the area of triangle ABC? Well, to find area, we need to find the base and the height of this triangle. I know that any radius I draw in the circle will be 4. And so I know that the hypotenuse is 9. One side is 4. I know this is a right triangle. So I'm going to find BC by using the Pythagorean theorem. 4 squared plus x squared equals 9 squared. 81. And that means that x squared is 81 minus 16, or 65. Taking the square root of 65, they gave us our answer in simplified form. Base 4 times height, root 65, over 2, because the area of a triangle is base times height over 2, gives us 2 root 65. C is our answer there. That's everything for you in this section. Let me know if you have any questions, and have a wonderful day.